In this video, we're going to be talking about lesson 2-5 and how to find the equations of a tangent line. Since the derivative of a function gives us a slope formula to find the slope of any tangent line to the graph of the function, the derivative can be used to find the equation of a tangent line. Now I want to point out that for the equation of a tangent line, the major part of the equation of a tangent line is the equation of a line. The equation of a line will require a point and a slope, because the only equation of a tangent line we use in this class, the only equation of a line we use in this class is the point slope formula. So y minus y1 equals m times x minus x1. So the point is x1, y1, and the slope is m. So the equation of a tangent line will give us, for the equation of a tangent line, we're going to use the derivative to get the slope. So we're talking about m slope equal to f prime, basically, or dy dx. It's that idea we're using. And we'll have to find some way to get to the point. Now, a lot of the times, what we're doing is we're going to be doing f prime of x1. And to get y1, that'll be f of x1. So those are two hints of how we can go about using one function to get us everything we need. Okay. Sometimes we'll want to find a line perpendicular to the tangent line. This is somewhat important. It doesn't come up a lot, but it's so easy. You should get these points every single time. The lines that are perpendicular to the normal line, perpendicular line to the tangent line is called a normal line. This formula is just expressing that perpendicular means opposite sign and reciprocal slope. So opposite plus minus, and reciprocal, we're rotating the fraction. Okay? Normal line. Whenever you hear normal line, the slope is opposite reciprocal. That's it. So, find the equation of a line tangent to the graph of f blah 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 at the point 1, 6. So, we need a point and a slope. Now, tangent line, we can find the slope of a tangent line by using the first derivative. So let's find f prime of x, the first derivative of f. 5 times 4 is 20. X to the 5 minus 1 is 4. 2 times negative 3 is negative 6. 2 minus 1 is 1. We usually don't write exponents with 1. The derivative of 5 is 0, because 5 is just a constant. The slope of a constant, the slope of a horizontal line, is 0. So that's f prime. I'm going to use that to find the f prime of 1. That's the slope of f at x equals 1. Slope of f, I know it always looks like slope off. Slope of f, all the way on the next line, at x equals 1. 20 times 1 to the 4th power minus 6 times 1, perfectly acceptable. But of course we could simplify that to 14. And again, putting this all together, we're talking about the slope of the tangent line at that point is 14. x1, y1, y, so Sometimes I label this as TL for tangent line. Y minus y1 equals the slope times x minus x1. Now this might sound silly to you. Just to be clear, this is the final answer. I've seen many students do this. They get so enamored with the idea that f prime is the slope that they begin to put the slope formula into this equation. Now, is this the equation of a line? Hopefully you said or thought, no way, that's some crazy function. Indeed. Bad. Remember, really? Remember, the slope is a number, okay? Don't mistake the formula for that number with the number itself. Careful. Now, normal line, the slope of the normal line is just the opposite reciprocal of that number, positive, so we're going to use negative, 14, so we're going to use 1/14. So the equation for the normal line, y minus 6, it's the same point, negative 1/14, x minus 1. Done. That's really it. The only way to make this more complicated is they don't tell you the point. They just tell you the x value they want. But to get 6, you could just plug in 1 to f, not f prime. 4 minus 3 plus 5 is 6. Go home or go and do some tangent line problems from the book now to solidify this lesson. Thank you for your attention. Good luck.